প্ৰিয় শিক্ষাৰ্থীসকল, কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক দৃশ্য শ্ৰাব্য অনুষ্ঠানটিলৈ আপোনালোকক স্বাগতম জনাইছো। স্বয়ং প্ৰভা DTH চেনেল 20ৰ যোগেদি শিক্ষাৰ্থীসকলৰ অধ্যয়ন কাৰ্য অধিক মনোগ্ৰাহী আৰু ফলপ্ৰসূ হোৱালৈ লক্ষ্য ৰাখি বিভিন্ন বিষয় সামৰি আমাৰ এই বিদ্যায়তনিক অনুষ্ঠানটি সজোৱা হৈছে। আহকচোন প্ৰিয় দৰ্শকসকল, আমাৰ আজিৰ খণ্ডটিৰ মাজলৈ আগবাঢ়ো।
Hello dear learners, I am Antara Baruah, Assistant Professor, Department of Electronics, HBC, School of Science and Technology. Today, in this video class, we will discuss about the combinational circuits. This unit belongs to the second block of Digital Techniques paper of first semester BCA program. This unit includes about the introduction of combinational logic circuits. Then we shall discuss some examples of combinational logic circuits like multiplexer and demultiplexer, encoder and decoder, and then we shall discuss about the adder and subtractor. So first let us see what is combinational logic circuit. A combinational logic circuits includes inputs, then logic gates and outputs. The output is depend on the present inputs values, and it does not have any memory, and if there are n numbers of inputs, then output will be 2 to the power n. So if there are n numbers of inputs, then the total possible combinations of inputs will be 2 to the power n combinations. And suppose n equal to 2, then total possible combinations will be 2 to the power 2 equal to 4. So 4 numbers of inputs will be there, and there will be m outputs. So output depends on the present inputs. Then let us see some examples of combinational circuits. Some examples of combinational logic circuits are multiplexer, demultiplexer, then encoder, decoder, then adder and subtractor. So multiplexer and demultiplexer are the very important combinational circuits, and let us first see what is multiplexer. So multiplexer is a combinational circuit which accepts many inputs and it gives only one output. It is also known as many to one. So multiplexer is also called as a selector, data selector, because it selects only one input out of several input signals to single output. So what is the relation between input and the control line is n equal to 2 to the power m. That means if number of input lines is 2, then number of control lines m will be 1, because 2 is equal to 2 to the power 1. So m will be 1. This control line, or we can say selector line, it will be 1 when input is 2. Again, if we consider input is 4, that means 4 numbers of input signals applied to a multiplexer, then number of control lines will be 2, because 2 to the power 2 will be 4. So similarly, the some examples of multiplexers are 2 to 1 multiplexer, then 4 to 1 multiplexer, then 8 to 1, or 16 to 1 multiplexers. Here output is always 1. So in multiplexer, the selector inputs determines the outputs. So for in this case we check about the 4:1 multiplexer. So first let us see the 4 to 1 multiplexer. Here we add a OR gate. So output is Y. As here the control line will be 2. Suppose A and B are the control lines, and the inputs are suppose data inputs D0. These are the 4 inputs: D0, D1, D2, then D3. And A and B are the control lines. Suppose A and B. Here a NOT gate is given. So how we apply the inputs to these gates? Let us see it from the truth table. Suppose A, B and output is Y. So for 2 bits, the input combinations will be 0, 0, 0, 1, 1, 0, then 1, 1. So first A and B is 0, 0. That means in the first gate, this NOT gate is 0, then B is 0. This will be the input. In the second case, 0, 1. That means A is 0. So from this line, then B is 1. So from this line. Here both the inputs is 1, 1, and we apply a NOT gate to make it a 0 input. Next combination is 1 and 0. That means A is 1. So here this is the line 1. Then B is 0. So it should be from the NOT gate. And the fourth combination is 1, 1. With both inputs A and B are 1. So from this line and this line. And output is when the inputs A and B is 0, the D0 output is selected. That means the other 3 AND gates are disabled and the first AND gate is enabled. So in the output of the OR gate, it will be data 0. And for the second combination, the output will be D1. That means the Y is the value of D1 input line. Then 1, 0, it will be D2. And for 1, 1 combination, output will be D3. So this is the truth table of 4 to 1 multiplexer, and this is the logic circuit diagram for 4 to 1 multiplexer. 4 means there will be 4 data inputs. So we have to draw 4 AND gates, and each data input is 4 input is applied to each AND gate. And the selector line or the control lines will be 2. So A and B are the control line, and we write the combinations for 2 inputs. Then accordingly we given this AND gates accepts the input combinations, and output is that means it selects only one input line at a time. So this is about 4 to 1 multiplexer. So multiplexers are used in various fields where multiple data need to be transmitted using single line. Some applications of multiplexers are communication system, in telephone network, computer memory, etc. Next, we will see the demultiplexer combinational circuit. In demultiplexer, it accepts only one input and it gives several outputs. So demultiplexer is also called one to many. So similar to the multiplexer, demultiplexers can be 1 to 2, 1 to 4, 1 to 8 or 1 to 16 demultiplexer. So now let us say the logic circuits and truth table of demultiplexer. This is a block diagram of demultiplexer. It has one input signals and many output lines, and M is the number of control lines. If the output line is N, then the input control lines will be 2 to the power M. So in case of 1 to 4 demultiplexer, that means output lines will be 4. So the input control lines or the selection lines, it will be 2. So M is 2. Now we see the logic diagram and the truth table of demultiplexer 1 to 4. Since output is 4, so there is 4 AND gates. Suppose output is Y0, Y1, Y2, Y3, and one input, that means suppose this is the D input, D is data input, and it applies to all the AND gates. Then in case of 1 to 4 demultiplexer, there is 2 selection lines. Suppose A and B. Here NOT gate is applied. So let us first see the output truth table, that is A, B, and 4 outputs. So 4 outputs is Y0, Y1, Y2, and Y3. So here I have written. First combination is 0, 0, then 0, 1, 1, 0, then 1, 1. So when the input is 0, 0, that means this 0, 0. Then the output, this D is selected at the output of the first AND gate. So Y0 will be D here. So what is the value is applied to the input, that is reflect on the output of the first AND gate, and the other AND gate are disabled, and the rest of the output of the AND gates are 0, 0. For the second combination, that is 0, 1, here it is 0, then next is 1, then the output of Y1 takes the data input, so D is here. If D is 1, we can write here 1, 1, and rest of the outputs are 0, 0. For the third combination, 1, 0, that means A is 1 and B is 0. For this combination, the output is reflected on the Y2, that is output of the third AND gate, and the for last combination, that is 1, 1, 1, 1. The other 3 outputs is 0, here it is 0, and it is 1. So this is the logic truth table of 1 to 4 demultiplexer. So what is the value of input? It reflects on the outputs. For other cases, it is 0. Similarly, same concept, we can draw the 1 to 8 demultiplexer, or 1 to 16 demultiplexer, or we can draw the 1 to 2 demultiplexer. So I have shown the 1 to 4 demultiplexer. So now demultiplexer is used to connect a single source to multiple destinations. Some of the applications of demultiplexers are the communication system, arithmetic logic unit, serial to parallel converter. In demultiplexer receiver, the output signals of multiplexer and converts them back to the original form of the data at the receiver end. Multiplexer and demultiplexer work together to carry out the process of transmission and reception of data in communication system. Next, we shall see the encoder and decoder combinational circuit. Here, the encoder is octal to binary encoder logic circuits. We will see. Here, if 2 to the power n is the inputs, then output will be n outputs. So in the block diagram of the encoder is like this. So this is an encoder. If 2 to the power n inputs, then n numbers of outputs. So it is 2 to the power n into n encoder. And here if this 2 to the n is equal to 3, then 2 to the power n is 8. So this encoder will be 8 into 3 encoder. Three output lines and 8 numbers of input lines. So encoder is generally used to encode the inputs, encode the informations. Now let us see the logic circuits and the truth table of 8 into 3 encoder. This encoder is just the opposite of decoder. First we will see the logic truth table. First we will see the truth table. That is, the inputs are 8 inputs. So I0, I1, I2, I3, I4, I5, I6, I7, and outputs are given as O0, O1, O2. So here is O0, O1, O2. So first, suppose the first input is high, that means 1 is applied to the first input and the rest of the inputs are 0. So in case of encoder, at a time only one input is high. Then what will be the outputs? This output will be 0, 0, 0. Then for the next input 1, rest of the inputs are 0. Output is. Now this is the truth table of 8x3 encoder. Here what it is given, that means at a time only one input signal is high, and for the outputs will be similarly these are the outputs of the encoder. So what we have seen, the output O0, that means first output is 1 when the I4, I5, I6 and I7 is 1. Then output O0, that means first output is high, and for the other cases the output is 0. Again the output, second output, that means O1, what it is saying, this output is high when the input I1, then I3 and I6 and I7 is high. So the output equations can be written as O0 equal to, when O0 is high, when I4 plus I5, then I6 and I7. Then for the next output O1, when this output is high, first I2 plus, next is I3 plus, here for this combination I6, and for the last combination it is I7. And for O2 it is 1 when I1 is high, next is 1 when I3 is high, plus next 1 I5 is high, and it is 1 when I7 is high. So this is the equations of output, three outputs O0, O1 and O2. Now this is the truth table. Now we draw the logic diagram of 8x3 encoder. Here three outputs, so these are the combinations. So here they all are last the inputs, so we used 3 OR gates, and in the 3 OR gates output is O0, O1 and O2, and here one unable input, that means to enable the chip unable input is applied, and this unable input is applied to all the 3 OR gates. Now for O0, what are the inputs? I4, I5, I6 and I7. So here as I0 is not, when I0 is high, no one output is high, so I have not given here I0, I have started from I1. So for output O0, this I4, then I5, then I6 and I7. So these are the inputs for O0. Then for the second output O1, what are the inputs? I1, I3, I6 and I7. I2, first is I2. So here it is I2, then I3, I6. Here we have given, then I7. So these are the I7. So 4 inputs. Then for O2 combinations, the input combinations are I1. This is the I1. I1, then I3. Here already this drawn I3. I3, I5, I5, and I7. So I7. So this is the logic circuit for 8x3 encoder. So I think it is clear now. Again I am repeating. First you draw the truth table for 8x3 encoder. There are 8 inputs. So I have marked here I1, I0 to I7, and 3 outputs O0, O1 and O2. And at a time it is assumed that at a time only one input is high. So accordingly this truth table has been drawn here, and when the output is 1 we have checked the inputs. So when output O0 is high, these inputs are high. So we have combined it, added it, and then we get the 3 outputs. So this is the logic diagram of 8x3 encoder. Next we will see the decoder circuit.
UGC, DV and Government of Assam recognized PhD, MPhil, Masters, Bachelors, Diploma and Certificate programs with online learning facilities brought to you by Northeast India's first and only state open university, Krishnakanta Hendik State Open University. Education beyond barriers. For admission and all other information, visit www.KKHSOU.in and subscribe for admission alert.
ইমান সময় আমি স্বয়ং প্ৰভা DTH চেনেল 20 যোগে সম্প্ৰচাৰিত কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক অনুষ্ঠানটিৰ আজিৰ খণ্ডটি উপভোগ কৰিলো। এই বিদ্যায়তনিক অনুষ্ঠানটিৰ জৰিয়তে শিক্ষাৰ্থীসকল নিশ্চয়কৈ ভালেখিনি উপকৃত হৈছে। পুনৰ আন এটি বিষয় লৈ আমি আপোনালোকৰ মাজলৈ আহিম। নমস্কাৰ।